Hello, welcome to Econometrics Melody. This is the second video on miscellaneous series and Stata. In miscellaneous series and Stata, we'll try to cover some of the basic, general, and handy topics in Stata. This series is going to be more of a practical session. Let's begin. Let us clear everything that is in the memory. The dataset in the memory will be cleared, and let us clear the output or result window as well. Let us set our observations to 21 this time. Again, 21. The data container for 21 observations are ready. Let us generate a time variable. Let us write gen t equals to, let us say, this for n. If we execute it, so this is the nth observation. We get this result. And if we want the first observation to begin with 0, we can subtract -1 from here, and we can get the same result by other functions as well. Let us try them. Let us use egen command. Egen, let us a equals to sequence. We begin from 0, simply 0. Okay, and if we get this, we'll get this result. And another way of doing this is using Mphil command. Let us try that as well. Using b equals to Mphil, and we should provide a certain pattern. If we write 0 and 1, so it will increase, the number will begin with 0 and increase in the difference of 1. So we should get the same result. So let us drop a and b. We don't require that. Actually, we are going to learn about time set in this video. Now let us treat this variable t as a time variable, so we need to format this. Format the variable t, and let us make it semi-annual data or half-yearly data, and the Stata will display the format. So the half-yearly data from 1960 all the way to 1970 first half year. Let us generate other variables. A are uniform, and the uniform random uniform distribution. It will generate a random number of the uniform distribution between 0 and 1. And if we want 2 digits number, we can always round it and then multiply it by 100. So this would give us 2-digit number. And let us generate another variable b using same function, but this time let us multiply it by 300. So this should ensure at least some of the observations to be 3 digits as well. Now let us draw the line graph. Let us draw the line graph of a, b, and t. And let us name it age a and replace it. So what does this do? The last variable that we have mentioned, it will act as the x variable, and the preceding variables, they will act as a y variable. We are going to get the graph of, actually it is a time series graph of these y variables a and b across time variable t. And let us run this graph. What does it look like? So this is the result, and we can get, now let us, we have mentioned t as our time variable. Now let us time series, t is time series, and yes, it's it. We set or we declare the variable t as time variable, and now let us try to get this same graph but in another form using Tsline. So once we specify this Tsline, no need to mention the time variable. We have already set t as a time variable, so we need to simply specify the y variable only, ab, and let us name this age graph b and replace any other graph by name b with this graph. And let us run this, and let us compare it combine it, combine the both of them. Combine A and B, and let us give it a title. Line versus Tsline. We should get that. If I combine this, both the graphs are one and the same. So the first graph A, we didn't declare t as a time variable, and we give the graph by mentioning x and the y variables to the first method, and the function that we have used is line. And in the second, we have explicitly declared t as a time variable. After that, we mentioned only y variable because the x variable is t itself, and there's no difference in the graph, they are one and the same. So this is it for this tutorial. Thank you very much for your time. Thank you very much, Econometrics Melody.